Hello guys, so welcome to another video. Here I want to show you how to calculate for the Ecut using a calibration plot. So it's going to be a convergence test that we are doing in this particular one. So I'm going to run Ecut for different cutoffs. Note that the cutoff is supposed to truncate the wave function because the basis set you are using is delocalized. So we are using the wave function as the basis set, which is delocalized and infinite. So we are truncating at a point. And in another video, I explained that the accuracy of your result depends on the size of the basis set, but if it's too large, it comes with a cost. So we do the convergence test to cut it off at a point where it doesn't matter anymore. Okay, so let's do the editing. So what you have to do is to create multiple directories. So I'm going to start from 10, 20, 30, 4A, 50, 60, 70. Usually by 40 should have converged, but let's see. So we go all the way to 100, 90, 100, and then we are going to copy both the input file and then the PBS file to each of the directories. And once that is done, I'm going to open each of them for us to run the calculation in. So note we are going to run SCF. We are not going to do any optimization, so that in this calculation you should have done a geometry optimization for you to just try to tighten the accuracy of the energy you get out. So let's say this is an optimized geometry. You run a relax first, and then you put the optimized geometry back in, and then you run an SCF so that you don't end up taking too much time. The difference from each file has to do with the Ecut. So this file is 10. 10 times 8 will be 80 for the density cutoff, and then everything else remains the same. So I have to submit. I'll go to the PBS. First of all, I have to print the part where my input file is. So it's in Relax Ecut 10. Let me edit my SCF PBS file. Relax Ecut 10. So I'm just going to update the location of my input file. Then the file name is going to be scf.in to scf.out, so it's fine. And then I can qsub. Oh, that's a mistake. Qsub followed by the script name. So it's this way. And then we can go out to the next directory and do same. Open the input file and then edit the cutoff to be 20. 20 by 8 will be 16. So 160. And then we do same with the PBS file. We just add ecut 20. That helps. Ecut 20. And here as well. Ecut 20. And that's it. So Q sub the script. And then we go to 30. Times 8. 24. And we leave everything else the same. So I'm gonna repeat this for the others and then I'll come back. Brian, no my chum, I'll slap you, eh? Can't you just do something good without being forced? So what is your problem? That's why I don't want you to stay with me anymore. Who do you want to go to? Tell me so that I'll take you. Hurry up so that I take you and focus. Because you are distracting me. Everything that everybody will do, you don't want to do because it's hard. Don't know that if you are choosing easy thing, you come and suffer. Eh? You don't know. Huh? Uncle was not telling you in the car. The thing will be hard, but you have to get it done. Did you hear me? 60 times 8. You think what I'm doing here, I'm happy? Huh? You really think I'm happy? But I have to get it done. If no, hunger will kill the two of us. Alright. by 8. 560. Ben, don't be choosing easy things, okay, my love? Asanya, choose which one? Hard. When you grow up, life will be easy. Yeah. Okay, my love. Don't be choosing easy things, okay? 70. Let's go to 80. 80 by 8. 64. By 8. Fine. Today, what did you learn in school? What about science did you learn? Birds, mammals, reptiles. And you know reptiles are frogs. And two other creatures that are reptiles. Did the madam ask you for your book? The madam asked you for the book. Reptiles. Amphibians. Amphibians have wet feet, which means they only live on water or on land. And they live on both water and land. Okay. And reptiles. Reptiles live near the ocean. Like crabs, snapping turtles, and all those other things. Eland type of birds. They have beaks, feathers, and wings. A penguin is a bird. Fishes. They have scales. What are those two things called on a fish? The scale? The scale, I already mentioned that. The which one? The fin? Yeah. And what else? There's one more thing. The tail? It has another tail. What else? Scales. Gill. Gill. The gill. Where it breathes from. That's the one. Gill. What's that? What's that? A name that we
That's from A.
Hmm?
What's the name that's not from A?
Start from A over where?
A. A. The North America, South America. What's that A sound? I mean, North America, South America. What's that A sound? Australia.
Australia, Asia, Antarctica,
A sound. A sound.
Europe.
Yeah, Europe. Antarctica.
Brian, can I finish my video, please? Okay. Okay, so now that all the calculations are done, we are going to compute the or find out the Ecut value. So you take an Excel spreadsheet and use that for your data. So let's go to the first one. You vim the output file, or even better, let's grep exclamation from output file. And then we keep doing this. Go to 30. Then we do 40. Then we do 50. And we do 60. And we do 70. We go 80. Then we do 90 and 100. Now that we have the data, we can now plot. So you select the two columns with control, and then you insert a graph. So let's give it, so energy will be on the y-axis. Yeah, so my predictions were right. Just like I said, usually it converges at 40. But let's display the data points so that, yeah, so we can see that at 40 the data doesn't change much, but you should use diagrams like GNU plot to neatly plot this, where your total energy in Rydberg is plotted against Ecut, or you can also use Origin to plot this nicely and use it in your data communication. So usually, like I said, at 40, 50, the Ecut value would have converged for most systems up to like 60. Okay, thank you. Bye.